Hi, everybody. Thanks for being here. It's a pleasure to be back in New York after so many years, since there was a pandemic in between or something. And yeah, this is going to be our session on Android benchmarking and some other stories. My name is Enrique. Iury is my colleague, and we will be co-presenting this. So maybe Iury?
Yeah. So hi, everyone. So Iury, it's with an I. Not an L in the beginning. I'm mostly doing Android things at Klarna, building a browser. Yeah, these are some of my hobbies, basically.
And my name is Enrique. I'm an Android Kotlin GD, working mostly on Android and Kotlin and some Kotlin for backend. I maintain the Kotlin Weekly. If you haven't heard of it, it's a mailing list similar to Android Weekly, one email on Sundays with the news from the Kotlin world, no spam promise. And my hobbies are running and finances. This is my Twitter handle, if you're interested. So first, we will give a bit of an introduction about what's benchmarking, some of the relevant core topics that are important in this context, and we are going to present a few frameworks that we can use to benchmark our apps. And later we will explain a few strategies that we can apply on our CI/CD process to benchmark, analyze, and determine whether there is a regression happening on our software, when was that introduced, and how to fix it. So first, benchmarking, as per Wikipedia, is the practice of comparing business processes and performance metrics to industry best and best practices from other companies. Things that we typically measure are quality, time, and cost, which are very strongly correlated. Then a bit more Android specific. Benchmarking is a way to test the performance of our application. We can regularly run benchmarks to help analyze and debug performance problems and ensure that we are not introducing regressions as we introduce changes in our code base. And another topic which is also very relevant, profiling. In software engineering, profiling, it's also referred as program profiling or software profiling, is a form of dynamic program analysis that measures things like space, memory or time complexity of a program, the frequency and duration of certain function calls, etc. So first, 3 frameworks that are relevant for benchmarking from Google and how to use them. Micro benchmark, macro benchmark, and Junk stats. Android profiling. What we are using typically in Android is the Android profiler. Since Android Studio 3.0 is integrated in the IDE, before it was a separate utility that we needed to open, but now it's within the integrated with the IDE. It replaces the Android monitor tools, and it tracks things like CPU, memory, network, and energy. We need to make our apps profilable, and it's very useful to identify bottlenecks. By the way, we should first identify bottlenecks before starting to think about our benchmark strategy. The idea is that we can know for sure where are the bottlenecks in our app, but by using the profiling, we can identify them. This is the screen of the profiler, the one that we have integrated in Android Studio, and we have a few things here that are interesting. So in the point number 1 is the process that is currently being profiled. Then we can see the sessions on the left panel that we are actually running. We can start new sessions. And then on the right, we can see the timeline from the CPU, memory, network, and energy. We can move through that timeline. We can zoom in, zoom out, and see exactly what's the current status. For memory, this is how it looks in detail. We have a button that we click, and we force a garbage collection event. So we can take a snapshot of the memory at that given time and see exactly what's the distribution. So how much memory we have on Java, the native, graphics, or the memory stack, etc. And then, of course, when we have taken the snapshot, we can move through that timeline, zoom in or zoom out. This is the memory allocation panel. You can see when we take this snapshot, we can see the amount of objects that we have loaded in memory. So you can see that here on the left side, we see the classes that we have captured in this picture. On the right side, we can see the call stack, so which functions are we calling to determine this state, and see if at some point, for example, if we are executing a function multiple times, we could see that an object is being created unreasonably big, and we can more or less determine where the problem is. Now for energy, it's also interesting. We can see if, for example, our device is executing a lot of network requests, which are expensive in energetic terms, or CPU or is accessing the GPS hardware, and this is leading to an abuse of our battery. So first, framework, micro benchmark. Micro stands for small, right? So this micro benchmark helps us to profile or benchmark things in our app that are running many times, small things in comparison with the macro benchmark. So some examples would be a recycler view when it's scrolling, when we are performing data conversions or processing any sort of information. We need to add the dependency, this one from here at the time of giving this talk. You can see also that there is this GUnit word on the Gradle artifact that we are downloading, and that's because there is a few similarities between how GUnit works and the micro benchmark framework. In order to add it, we will need to add the run with annotation, specifying the Android GUnit 4 class, and this is how our hello world looks like. You can see that we have a benchmark rule. We need to annotate it with this get rule. And then we have the test. This is just a random sample that calls this measure repeat, and then within the block, we do some work. It could be in a real-world app, like processing some data, downloading an image, processing a bitmap, whatever you want. Because micro benchmark runs the code directly, you need to place the code you want to benchmark into a separate Gradle module and send a dependency on that module as it's on here. So we are going to have our app module, we are going to have the benchmarkable library, and then the micro benchmark library. Now, the hello worlds are a bit, it's good to start, but let's see something a little bit more elaborated. So in this example from here, we see that we are generating a random number and then adding this number to an array and then sorting it. So first, we use the random function to create the random object. We are going to add 10,000 items randomly to this array. And here we have the test, or the benchmark in this case. See that we are calling the same as we had in the before in the hello world, the benchmark rule.measure repeat, but here we do something a little bit more interesting. We copy the array into we take this array, the list to sort, and then start applying this method, the quick sort, which is going to be take some time to execute, and then the benchmark will give us information on how long it's taking to get everything sorted. If we want to run benchmarks, we can do it from the console. The command at the top will execute all the benchmarks we have on our project. The one at the bottom allows us to select given packages or benchmarks or do it individually in case we don't want to run the entire set, but just a specific one. If we run this from Android Studio, we can get this visual information on the benchmarks that we have been running. Similar to how a test works, right? On the left, we have the name of the benchmarks that we're running, and this is different from a test. A test is deterministic. It either fails or doesn't fail. But a benchmark doesn't fail or not fails or works or doesn't work. It always runs, but it will give us some information, how long it takes until this benchmark runs, and well, the amount of milliseconds, etc. And this can vary wildly between different executions. That's why later we will use a technique to identify potential regressions. Here in this case, we can see that one of the tests is taking whatever milliseconds, the other one is taking a little bit longer, etc. Now, micro benchmark. It's help us to test larger use cases of the app, so things like application startup, complex UI manipulations, running animations, etc. We need to make our app profilable. In order to do that, we need to add this to to our manifest in Android Studio and set up our Gradle configuration. You see that we have these build types where we typically add the release build and the debug build and maybe some, whether they have like a different package name or whether we apply ProWard or anything we want. And we need to add also this benchmark block where we specify the build tab that this is going to be running with and the signing config. And this will create a new build variant here, or a new build type. You can see here that we have, together with our module app, one at the bottom called macro benchmark that allows us to execute the benchmark directly from Android Studio. Now let's skip here the hello world and go with a more real use case scenario. This is how it looks. See that we are also applying the run with annotation. We can have something like a large test at the top, etc., similar to how a JUnit test work. In this case, we're going to create a benchmark rule, but note that this is a macro benchmark rule. It's not as we had on before. It was just a benchmark rule. This changed a little bit. And when we're executing this test, we will call method repeat from the benchmark rule that we have defined previously, and see that we are passing here a few interesting things. One of them is the package name. The other one is the metrics. The other one is the iterations, the number of iterations that we want, and then a setup block. In this case, we just press home, and we do whatever we want to do. And here we start the activity and wait. Now, the metrics. We have right now 3 metrics that we can apply. The first one is the startup timing metric that captures the app startup timing metric. So since we click on the icon and the intent gets called and the app gets into the screen and the splash screen finishes. We have also the frame timing metric that captures timing information from frames that are produced by a benchmark, such as scrolling or animations. And the trace section metric, which is still experimental at the time of giving this talk, and it captures the time taken by a trace section. Again, we can run this from Android Studio if we want to do it visually, and see that here is a little bit different right now. We have specified 5 iterations, so you can see at the bottom of the screen that we have from 0 to 5, and we get the minimum time, the median time, and the max time to execute this specific benchmark. Of course, Android Studio is comfortable because we click on a button, and then we get some information, but what happens if we need to run this, let's say, several times per day? And what happens if we want to track this through the course of 3 months? As humans, it's going to be very hard for us to go and see that once it was 748, and then later 749, and then 651. That's what my colleague Iury will go into detail later. And this macro benchmark execution generates this JSON file. This JSON file contains information about the package that has been running, how was the CPU state at that time, the minimum, maximum, and median time that took to run the given benchmark, etc. This is the source that we're going to be using later to determine if there is a regression or not, this JSON file that gets generated. And last but not least, JunkStats is a new framework. It was released on the 9th of February. At that time, I was working with my colleague Iury, and we had a presentation on the 9th of February, and this was, or the 10th of February, and it was presented, released the day before, so it was fun. And it's built at the top of Android, and it uses an in-app benchmark. This is how it looks like. We would have our, see, by the way, that this is done within the app. So this is a real activity, and then in the activity, we have these JunkStat objects that we create and initialize, and this will start determining the junk status within the app. This is the relevant code. This example injects the state information about the current activity after it constructs the JunkStat objects. All future frame data and reports created for these JunkStat objects will include the activity information of this junk logging activity. It has a reporting mechanism, similar to how, here you see that we have first this listener that returns a frame data, and in a real app we will be doing here more interesting stuff. This is just a log line. We print something on the log cat, but typically we will be writing something into the local storage and see what's the report about it. And this is the frame data object. It contains information about the frame start, the duration, whether it's junk or not. There is some heuristic to determine this. They're a bit complex, but if you Google something like JunkStats heuristics, Google, you will see more or less what determines in order whether this is a junk or not. And then a list of states of this potential junk. Now, aggregating. We can do or follow a similar strategies to what, for example, the Google Analytics or the Analytics SDKs have, which is instead of sending the data as it comes, we aggregate it first, make groups, and then report it later, so we don't have to do it every second. Can you see here any difference compared with the previous example? I'll give you 10 seconds. Any hints?
Performance metrics?
Sorry?
Performance metrics?
No, not that one. So I made this very annoying arrow, so you cannot miss it. So see that there is this junk stats aggregator instead of the junk stats object we had before. This essentially starts aggregating everything, and we need to manually invoke the reporter. So what we make by this is that it's not reported anytime, but we can aggregate first and then report. So we, for example, can do, typically this is the usage. When we start the app, then we make the is tracking enable true, so the junk status starts to work. Then when we pause the activity, we issue the junk report, and then we stop the tracking, so it doesn't work anymore. Typically, if we want to, like when the app finishes or whatever your scenario is, stops, junk status stops working. Because again, this happens within the app, so it's on the app that you're running, and the user installs on the device. So now you have now some nice theoretical background. My colleague Iury is going to put a few pieces together and explain you how to find regressions on CI.
Thank you. So yeah, now that Enrique basically laid out the tools available currently for benchmarking your app, now we can try to use some of those tools to automate some of these. And this is the part about detecting regressions in CI. So just to go on with the definition things that we've been doing. CI, just to get everyone on the same page, is that continuous integration thing. You get to merge correct code into the main branch, into your main code base. And regression is not the definition from the dictionary here, it's just performance degradation. So, so that's what we want to do, right? So we want to identify performance degradation in your app in the continuous integration environment. You may be thinking, why would you need this in the first place? I think Enrique went over a little bit of that, but just to go over again, this is a simple example of what might happen in your day-to-day work. You might be working with something, and then someone pings you and mentions there's a big performance issue on a certain feature, and then you have to switch context and start digging into the code and try to identify what's going on there, usually without a lot of context. And so that includes a lot of pain and manual profiling and benchmarking. So one of the advantages of doing that basically is that monitoring performance degradation is easier than profiling if you have something in place to already tell you that something's going on badly, instead of you having to actively going into looking for problems. This is going to help you catch problems before they hit end users, which is also nice. I mentioned this because some of you might probably have some kind of analytics tools, and you're already using that to identify issues with performance, maybe. The problem is that it's only reports to you after the fact. So you already have maybe millions of users with some kind of problem, and then you get a report, and then you start working on that. So the time until it fixes is going to be a lot of people with a performance problem in your app. So this is going to help you prevent stuff before these problems before they hit the end users, right? Also, running benchmarks is repetitive, error prone, as you probably know. Doing that manually is just not good. Something that Enrique mentioned, the output of benchmarking, the macro benchmark or macro benchmark, is just a number. So that doesn't tell you a lot. So you have to do some kind of manual comparison and try to identify if that's actually bad or not. And in the end, ideally, we want to automate this kind of process, right? So we don't have to deal with all these problems. So This is just a kurzgesagt animation to talk about how automating is good. Right, so we're going to go over a basic example, like how to monitor performance degradation in app startup time. So this is a common problem, I guess, with most apps. If you don't do anything about it, that's gonna take some months, and suddenly someone's gonna tell you that the app startup is just too slow because people just adding a lot of stuff in startup. Right, so the solution for that, like one of the tools we're going to choose, is a macro benchmark startup timing metric. This is going to be just the tool for this scenario. So let's go over with the example. What you have to do, you install the APK on the device, and then you install, and then you install the macro benchmark instrumentation, which is a Gradle command basically that's going to install like a separate artifact, like I think Enrique showed. This is just going to behave like a puppeteer controlling the puppet, which is your APK. So there's a separate process that's going to interact with your app. So this is just to tell that it's a pretty isolated process. It's not going to mess with your APK or your original APK. Then you're going to run the macro benchmark tests, and this startup timing metric is going to generate this benchmark data.json, which has all the data that Enrique was going on. And then you just have to store the data. So these are the three basic steps. You install the artifacts, you run the macro benchmark tests, and you store the output. So we have some questions about that. Well, when to run that? We don't have a clear answer for that. Like, you could do this on every build, but that might be costly depending on your app and depending on your structure. You may want to run this on maybe on every release build, or I don't know, maybe every 10 builds. This is going to really depend on your scenario. The other question is where to run this, right? So ideally you have to run this on real devices because they're going to yield better data. You can use a tool like Firebase Test Lab or a device farm that you have access to, just to tell that you want to run this on a real device. Then what to store, right? So we want to store the performance metrics. So basically it's just times in milliseconds and the corresponding build number. So we have a key value pair of the build and the time it took to run the benchmark. This is the basic setup, right? So now what? Now comes the detection part. So there are a bunch of possible approaches for that. We're going to go from the basics until the more sophisticated ones. So the most basic one, I think, is something like this, right? So you have the current build startup time, and you compare with the last. If it's bigger, then it means it's a regression. But you shouldn't do this because obviously there's a lot of variation in the metrics, right? So the macro benchmark library, it already sets a lot of stuff up to try to make that variation not be that big, but still not perfect. So you're going to see there's going to be a lot of variation. A lot of processes can kick in the background, and you don't control that, right? So you only control your app, so you don't control the whole device. Something might go on with CPU or anything. Basically, a lot of things can change between runs, right? So you may be thinking about the better approach would be to set up like a threshold value. So you have like a number you define, I don't know, 15%. So everything below 15%, you're going to consider a noise. So you're not going to count that as performance degradation. But that in the real world also has some problems. Like imagine that you have these values here. You have in your build. On the vertical line, there's the time. On the horizontal is the build number, right? So you have this data, and then this happened. Is this a regression or not? Depending on the threshold, you may say yay or nay. But if this happens right afterwards, then that wasn't really a regression. So you have some inconsistency there. So what happens is that if you have a fixed valid threshold, you're going to have false alerts, basically. And the worst is that you're also going to miss regressions that was just below the threshold. So if you have always regressions of 10%, then after a while it's going to be a lot, but you still didn't account for them. So the thing is, we can do better, right? So one of the setting up some constraints of the solution we want to develop, we want to handle this temporary instability, and we want to avoid a manual tuning per benchmark, right? So you don't want to be changing the number every time you run the benchmark just because of the last builds. And we want some kind of accuracy. So instead of saying that now comes the detection part, I think it's more accurate to say that now comes the math part, right? So this involves a little bit of math, not a lot. I know it's early morning, so we're going to try to make this not that bad. We just basically need a context to make this kind of decision. So there is a solution for that already. Other fields have already been using this for a long time. We can steal the idea to computer science into our case. There's an algorithm called step feeding. It's a step feeding function if you Google that. If you can Google that. This is a statistical approach for detecting jumps or steps in a time series. So you have a lot of data, there's a lot of noise going on, but you want to identify when there's actually a jump. So this strategy has been already adopted by Jetpack Compose team. We're gonna mention some resources at the end, so you guys can take a look at that. It's interesting. So, like I said, early morning, I'm not gonna go into the detail of the algorithm, but it's basically a sliding window. If you've ever done some kind of lead code, you've probably seen those. It's a sliding window. What the idea is, you're going to compare a particular build value, the benchmarking value of a particular build with the context around that build. So that window on both sides. So this is going to give you a context of if that degradation happened in the context of that window, not in the whole time series. So this is going to increase the accuracy. And you have some parameters that you can change, that you can tune for your particular application, which is the size of the window and the threshold. So you still have a little bit of both worlds you can control, and you also improve the accuracy. Just a basic example, imagine you have this time series again, and this is like the median code startup time from the macro benchmark library. This is giving this data, and you've been storing like we decided to do. So we have the time and the build number, and then this happens. So you want to identify if this is a regression or not, right? So if you put in this, the step feeding algorithm, you're going to have the data divided in this, the width. So you have this window, one side, the other side. You apply, you compare that, the build with the green arrow with that context in that window. And you apply the step feeding algorithm, it's going to tell you, no, this is not a regression. Because in the threshold that we're using, that's not considered a regression yet. But as you move, as you get more data, and more data, and more data, then it comes to a point that it's okay, it's safe to say that this is a regression now. Maybe that you want to take some action here. And this is important. It's really hard to say like, okay, this is definitely a regression, break your build. You're probably not going to want to do that, but you may want to have maybe a Slack message saying, hey, there's something weird going on, please check. So if you're doing this on your CI environment, this is hopefully going to warn you before you release to users. So you have a window to try to revert or fix or just acknowledge that happened. So to recap, detecting out regressions in CI, you can automate the regression detection key points of your app. So you can set up a particular place to monitor. You may want to use the step feeding instead of the other naive approaches. And if there's a regression or improvement, because this is also interesting, if there's improvement, there's might something going on too, like something weird is going on. Just trigger an alert and have someone check that. you're going to look for issues in the last width of builds, and this is going to help you catch the issues before they hit the users. And back to Enrique.
Yeah, and more recap on Jetpack benchmark. It offers us micro and macro benchmark, and we use the instrumentation test as benchmarks. Junk stats, the third leg of the table, we need to use it on real devices. It contains a reporting mechanism to let us know about the junk that is happening on the app, and it's the latest benchmark library from Google. Profiling, it will help you to identify potential bottlenecks in memory, energy, network, or CPU usage, and we should use profiling to identify bottlenecks and then implement our benchmark strategy and not the other way around. Last but not least, we would like to give you a few resources. We'll upload later the slides in Twitter, but just in case you want to take a picture now or whatever. There is this super nice article on fighting regressions by Chris Craig. He explains how they actually identify the regressions, how they use CI/CD to implement their mechanism, a few visualization tools. The one from Chris Craig?
Yeah.
Okay. Yeah, then we have the benchmark official documentation. Also, if you Google something like benchmark official docs, you'll reach out. And then all the information about the Junk stats library. There are actually a couple of more sessions here at the DroidCon on performance, so if you want to check them out, they will be useful as well. We definitely plan to check them out, one by Ryan Brooks and another one by Steve Lerner. And of course, if you want to give us some feedback, we would highly appreciate it. If you take, well, this QR code leads you to bit.ly benchmark feedback, and you can download the slides from the link at the bottom. Well, not sure if anybody wants to take a picture. Yeah, that has been everything. So thanks for being a fantastic public. If you have learned something new today, I think our target here has been accomplished. And if you have any question and we know the answer, super happy to answer you. Thank you very much.